But the camera is recording. Okay. So it is the number of particles, this is our definition, in 12.01 grams of carbon. And so we would normally take some time to go through this and to talk about how the carbon-12 isotope has 6 protons and 6 neutrons, and we use that to figure this out. And Avogadro came up with a number based on mathematics, but we're skipping that part this year. We're going straight to simply learning and knowing, sorry about that, that Avogadro's number. And kind of ironic that we're writing it in green because Avogadro reminds me of avocado. And so, yeah, Avogadro's number is 6.022 times 10 to the 23rd particles. But that label doesn't always have to be particles. It could be atoms. It could be molecules. It depends on what the thing is that we have a mole of. Similar to how a dozen is equal to 12, you will now associate a mole with 6.022 times 10 to the 23rd. And I'm going to just write the word units. So, if 1 mole of carbon is equal to 12.01 grams of carbon, where did this number come from? Any guesses? We're going to round these to 2 decimal places. So 1 mole of aluminum is equal to how many grams of aluminum, according to our periodic table. And I like to use the shape of the triangle to indicate go to your periodic table. And I'll only do this a couple times and then I'll stop. Oh, I got a hand and I don't see who it is. I apologize. All right, Daniel B., what do you got?
26.98.
I got 26 point... Wait, you got 98? Oh yeah, 98. All right, how about, Diego, I know you had your hand up for aluminum, but how about a mole of gold? You want to take that one? Oop, and there's a check. Oh, thanks, Keely. All right. Oh, I thought you did. Sorry, Diego. Sherry. I thought you had it up for the aluminum one. Or maybe you... Anyway. No worries. How about for gold? Its atomic number is 79. All right, Haley Nelson.
196.96.
I agree. 196.96. Okay, let's do one more. Mole of copper. All right, Ben.
63.55
Beautiful.
grams.
Yep. Okay, so now let's take this information, and I'm going to need a second page. So let's look at this from the point of view of a compound. And I'm going to use my favorite compound, glucose, because I miss my days of teaching biology. So C6H12O6. And I put that in the middle of my paper for a reason. I'm going to put molar mass over here. And I'm going to put formula mass over here. So if I want the mass of a mole of C6H12O6, here's what I'm going to do. I've got carbon. There are 6 of them. Times 12.01 is going to give me 72.06. Hydrogen. There are 12 of them. Times 1.01. So 12.12. Oxygen. 6 of them. Times 16.00. So if I add all of those up, I get 180.18. Notice that for now, I didn't put any labels on here, because the molar mass is the mass of a mole, while our formula mass is the mass, I'm going to go this way, of one molecule. So my label is going to be different, but the process is the same. So my label for molar mass is grams per mole. My label for formula mass is AMU, atomic mass units. So what's the difference between these? Well, 95% of the time, we're going to use the molar mass. Formula mass typically is a test or a quiz question. We don't normally use that for conversions. Okay, so we have quite a bit of information here. What I want to do right now is take a 1-minute stretch break. Back, Overrocker, come back, come back. Okay, so Diego, to answer your question again, how do I know whether I use grams per mole or atomic mass units? If it's asking for molar mass, grams per mole. If it's asking for formula mass, AMU. 95% of the time it will literally be this. The only time this is going to be like a test question, like what's the formula mass for glucose? Okay. Next, oh, I should have paused the video. Too late. All right, let's do some examples, because I think we have a lot of conversion factors here, right? Like we've got grams per mole. We've got moles per gram. we said earlier that Avogadro's number, like a mole, contains 6.022 times 10 to the 23rd particles, or there are 6.022 times 10 to the 23rd particles per mole. Yep. Literally, Diego, only the label. When you use atomic mass units, that's the mass of one molecule, a single molecule. When you have molar mass, you have the mass of an entire mole instead of one molecule. So that's the only difference. The process is the same. You get them from the periodic table the same way. Legit, the only difference is one is for like a single molecule, the other is for an entire mole. All right. So now we've got these conversion factors. Let's do some stuff with them. Okay, yeah. So really and truly, not the only difference is whether you're, whoa, where'd you guys go? There we go. Whether you're taking the mass of one molecule or an entire mole. All right, so let's do an example. Example 1. If I have 100.0 grams of water, how many moles is that? So 100.0 grams of water contains how many moles of H2O? Okay, so just like any other problem, thinking way back to when we did conversions before, we're going to have something that we're given in the problem, and we're going to have something that we're trying to find. So I'm going to start with what I'm given, the 100.0 grams of H2O. I'm going to make my little picket fence. I'm going to take my grams of H2O, put it on the bottom. Moles of H2O. I believe, oh, hey, look, that's the molar mass. So I got 1 mole, and then for H2O, I go to my periodic table. And I have hydrogen. I've got 2 of them times 1.01. I've got 1 oxygen times 16.00. So the molar mass of water is 18.02 grams per 1 mole. My label crosses out. Through the magic of mathematics, I take 100 divided by 18.02 because the 18.02 is on the bottom. And my calculator answer is 5.54938 moles of H2O. Sig figs, there are 4 sig figs back in my original problem. So I need 4 sig figs for my answer. So 5.549 moles of H2O is my final answer. questions on that problem? Do. Giving some time. Jeopardy still in my head, waiting for questions. How do you do the end again? Like the sig figs, Lauren? Or the math? Very good question. I went back to my original problem and I have 4 sig figs here, 100.0, because my trailing zeros with a decimal are significant. So when I took 100 times 1, which you don't have to do, divided by 18.02, I got this 5.54398, blah, blah, blah. And then because I want 4 sig figs, keep it, the 3 makes that 9 stay the same. So then I round that to 5.549 moles of H2O. No and no. Diego. Example number 2. I'm going to flip to the next page. See. All right, next example. .92 moles of CO2 contains how many molecules of CO2? So 4.92 moles of CO2 contains how many molecules of CO2? Okay. Here's what I'm given. Here's what I'm trying to find. So I'm going to start with what I'm given in the problem. 4.92 moles of CO2. And I'm going to build my picket fence. Once I build my picket fence, the first thing I always do is take my moles of whatever's here, whatever label is there, I put that at the bottom because I want it to go away. That process is always the same. So now, here's a question. Moles of CO2, do I know how many molecules of CO2 are in a mole of CO2? I think if I flip back to my first page, the answer is yes. In 1 mole, I wrote down that there are 6.022 times 10 to the 23rd molecules in a mole. Stay with me, Diego. Jot this stuff down. Moles crosses out, and now I just do the math. So 4.92 times 6.022 E23 gives me 2.9628 times 10 to the 24th molecules of CO2. Looking back for sig figs, 3 sig figs. So my final answer is 2.96 times 10 to the 24th molecules of CO2. So 100.0 grams of water contains how many molecules of H2O? Okay, so raise your hand when you've written down the question and you're ready for me to start working it out. Okay, and Diego, for real, this is new stuff. It's not going to probably make sense until you try to do some problems. And that's okay. All right, so, and in the problem, I'm given 100.0 grams of water, and I'm trying to find molecules of water. This one is going to take us 2 steps because I don't know how many molecules are in grams. There was nothing that we talked about earlier. So 100.0 grams of H2O, build your picket fence. Take this label and put it on the bottom, just like you have every other problem when we've done any conversions. All right, so I don't know how many molecules and grams, I don't know a relationship there, but I do know that the molar mass contains grams and moles. Right. So I'm figuring out where my labels go based on what I need to go away. Looking at the periodic table, I've got 1 oxygen, which is 16.00, 2 hydrogens. So the molar mass of water is 18.02. So now I'm going to build some more fence. I'm going to take the moles of H2O, put that on the bottom, and then I'm going to put molecules of H2O on the top. Because I know from earlier that 1 mole contains 6.022 times 10 to the 23rd molecules. All right, when you have that all written, put your hands down, please. And then my moles crosses out. And remember, this is Avogadro's number. All right, Allison, did you just put your hand down and raise it again? Okay, it kind of did a little flash thing, so I was wondering if you were trying to get my attention. Okay, so are we ready? Put your hands down if you're ready to do the math for this. A couple people are still writing, and that's fine. Lily said that her computer died. Oh, tell her that this is going to be recorded, and, well, oh, there she is. She's coming back. All right. So Daniel B., whenever you're ready. Or do you have a question? Is that why you still have your hand up? Sorry. Okay, I'm gonna assume that he's ready, just can't put his hand down. Okay, so now here's the math. We've got 100 divided by 18.02 because it's on the bottom, times 6.022 E23, and I got 3.3418 times 10 to the 24th molecules of water. 4 sig figs, 1, 2, 3, 4. The 8 is going to make that one round up, so my final answer is 3.342 times 10 to the 24th molecules of water.